Hello everyone, I'm thrilled to have you join the online course Easy Geosteering. We make complex geosteering topics simple by breaking them down into easy-to-understand concepts. We are currently in the second part of the course, BHA components, and in the previous video we covered telemetry signal and data density. And today we will continue with MWD surveys. Let's get started. As we mentioned in the first video, MWD survey consists of measure depth, which is tracked on the surface, and inclination and azimuth, which are measured by the downhole tool. Let's focus on inclination and azimuth, starting with the survey procedure. The most common survey frequency is one stand or 20-30 meters MD. However, it can be more frequent, such as every 10 or 15 meters, depending on the survey program for a specific well. After drilling one stand or one pipe, we need to perform the reaming procedure. First, BHA with rotation is moved up and down several times to clean out drilling cuttings from the bottom. Then we stop the top drive and move the BHA without rotation to release the spring effect, a phenomenon where the drill string accumulates elastic deformation and then releases it in the form of unpredictable BHA movements at a random moment. Since the accelerometers require the BHA to remain completely still during taking a survey, this step is critical for survey quality. Then we need to position BHA 1 meter from the bottom to reduce the blind zone. Step number 4. Turn on the pumps. MWD tool measures the bottom pressure, and the pressure decrease signals that it's time to take a survey. Here the tool uses accelerometers and magnetometers to obtain 6-row axes, GX, GY, GZ, and BX, BY, and BZ, which are used for inclination and azimuth calculations. Then we need to allow necessary time for the survey measurement. Some tools complete it in a few seconds, while others require about a minute without much circulation. After that, we turn the pumps on, and the pressure increase signals that it's time to transmit the 6-row axis to the surface, where software will calculate inclination and azimuth based on them. So, every time when we turn off the pumps and then turn them on, MWD tool will send us the survey data. After that, the tool will continue transmitting client curves until the next time the pumps are turned off. Okay, we have covered the survey procedure, and now let's dive deeper into the 6-row axis. The DNI sensor of MWD tool has 3 mutually perpendicular accelerometers and 3 mutually perpendicular magnetometers. Let's start with inclination measurement. One accelerometer coincides with the tool axis, while the other two lie in the plane perpendicular to it. In our example, the axis vector is GZ, but in other cases it can vary. So, the basis for inclination measurement is the Earth gravity field. In space, the gravity vector is uniquely decomposed into 3 vectors, giving us 3 values, Gx, Gy, and Gz. The value of G2 is then calculated as a square root of the sum of the squares. After that, we can calculate cosine of inclination as relation Gz to G2. All these formulas are contained in the software, and all calculations are performed automatically. We just need to understand that inclination depends solely on the 3 accelerometer vectors, and this measurement is relatively precise, since only one correction may be applied, such as SAG, correction for tool bending. Okay, with azimuth we have a more complicated situation, because the basis for measurement is the Earth magnetic field with a more complex structure. While the gravity vector is always directed downward, the magnetic field resembles a shape of toroid. At a given point, the magnetic field is described by 2 components, B-total or magnetic vector itself, and dip angle or the angle in the vertical plane between B-total and its horizontal projection. Please don't confuse it with the formation dip. Actually, azimuth is the angle in the horizontal plane between BZ axis and the horizontal projection of B-total. Determining azimuth requires complex trigonometric formulas. However, you don't need to memorize them. Just know that azimuth depends on all 6-row axes. And this is the first reason why azimuth measurement is not as precise as inclination. The more inputs, the lower the accuracy. The second point is that many factors affect azimuth. BHA interference, solar activity, magnetic rocks, magnetic drilling mud, nearby wells with metal casing, and so on. Some of this can be modeled and corrected, such as BHA interference and solar activity, while others, like magnetic rocks, cannot. Alright, we have covered MWD surveys. Hope you liked this video. Remember, you can elevate your geosteering skills with the private lessons. Together we will work in StarSteer to utilize all modern geosteering tools and drilling simulators, and to immerse you in a realistic scenario as a true geosteering engineer. So stay tuned and give this video a thumbs up. In the next lesson we will explore MLWD logging. See you then. Bye bye.